Target 6.5. Given the reactants of a double replacement reaction, I can predict the products. We already learned how to do that. Write a net ionic equation and identify the spectator ions. So we will focus on net ionic equations and spectator ions for double replacement reactions. Now, we talked about earlier that there are 3 subcategories for double replacement reactions. Precipitation reactions produce precipitates. Here's a picture of a precipitate forming when 2 clear liquids are poured together. Precipitate is a solid, insoluble solid that forms when you mix 2 solutions together. Gas forming reactions produce gases like carbon dioxide and ammonia. You have to memorize this. When you predict the products of a double replacement reaction and one of your products is ammonium hydroxide or carbonic acid, if that happens, you just have to memorize the fact that ammonium hydroxide further decomposes into ammonia gas and water. Carbonic acid further decomposes into carbon dioxide gas and water. Therefore, gas forming reactions. A gas is formed here and a gas is formed there. Now, when you see these kind of reactions, it doesn't look so much like a double replacement because you end up having 3 products on the right side of the equation. The third subtype is acid-base. These are easy to recognize because the reactants are an acid, starting with H, and a hydroxide, OH. And the products, you'll always have water produced and a salt. So those are easy to recognize. We'll go into more about those later. Writing net ionic equations. We're going to focus on precipitation reactions first. Steps for writing. For example, this is what you would be given. You would be asked to write the net ionic equation for silver nitrate reacts with potassium sulfide. First thing, predict the products by trading partners. So, silver nitrate reacts with potassium sulfide. You'll put silver with sulfide, potassium with nitrate. So it's going to be, don't forget to cross over your charges, A2 or Ag2S plus potassium nitrate. They're both 1, so it's KNO3. Now, we've predicted the products. The next step, add phase notation. For these type reactants are going to be AQ, so always put AQ on your 2 reactants. And then you will have to use your solubility chart to see what the phases of silver sulfide and potassium nitrate are. If both of these are soluble, they're both AQ, and then you would just write no reaction and stop here. So let's go ahead and do that. We said our reactants are always AQ. We check the solubility chart. Alkali metal with anything is always soluble, therefore AQ for KNO3. Silver sulfide. Silver sulfide is insoluble, therefore solid, therefore yes, a reaction takes place. The next step, balance the equation. So to balance this equation, I would, since I have a 2 here, I would go ahead and put a 2 there to fix silver, and that gives me 2 nitrates as well. So I will have to come over here and fix that by putting a 2 there, fix my nitrates, then that gives me 2 Ks, which is okay because I already have a 2 there. Therefore it's balanced. Next step, separate all of your AQs into the ions. Leave the solids intact. So this is the complete net ionic equation. I have 2 silvers, so I would write 2 Ag plus aqueous, make sure you include your charge there. I also have 2 nitrates, so 2 NO3 negative AQ. I have 2 Ks, so 2K plus AQ, and 1 sulfur sulfide ion. S negative 2 AQ. Do the same thing for the other side, 2 Ks, so it'd be 2K plus 1 AQ. 2 NO3s, AQ. Leave the solid intact. Do not separate it into its ions. Excuse me. Next step, once you've written your complete ionic equation, then you separate out any ions that remain AQ on both sides. For instance, let me just erase these and start over. Here's my complete ionic equation. I look to see if silver on this side is AQ, but on the right side of the equation it's in a solid, so I can't cancel it out. Nitrate is AQ on this side, AQ on that side, so nitrate will be canceled. That's a spectator ion, meaning it always stays in solution. K is AQ here and AQ there, so again, spectator ions, they just stay in solution and do nothing. What we're left with is our net ionic equation. So we rewrite what we're left with, what I didn't circle, 2Ag plus S negative 2AQ and Ag2S. This is the net ionic equation. Remember, if everything is AQ, then nothing happened, just write no reaction. We'll work through another example. Identifying spectator ions, those are the ones that I circled that stay aqueous. They stay dissolved and basically do nothing. Therefore, they're never part of the precipitate or a gas. So that's why they're called spectator ions. What's actually happening, for example, if we took iron 3 chloride and dissolved it in water, it would separate into its ions. Sodium hydroxide dissolved in water, it would separate into its ions, and you would have something similar to this. Iron 3 ions and chloride ions, sodium and hydroxide ions. But what happens if you pour these two together? Will anything happen? Well, what would be the possible products of this? Possible products would be iron hydroxide and sodium chloride. So FeOH3 plus NaOH. Use your solubility chart and see that this one is AQ, no solid will form, but hydroxides are insoluble, therefore a solid. So yes, what will happen is that iron hydroxide will precipitate out as a solid. So write the molecular equation for this. We already said that it's iron 3 hydroxide and sodium chloride. Let's go ahead and balance that. We have 3 chlorine, so if I put a 3 there, then I would need to put a 3 here to fix my sodiums, which already fixes my hydroxide. So now that's balanced. Now I need to phase these. We said that this one dissolves in water, so it's AQ. This one is your solid. To write the net ionic equation, or the complete ionic equation, separate all of your AQs into its ions. So I have 3 Na pluses, aqueous. We also have 3 hydroxides, and that's AQ. We have just 1 Fe plus 3, that's AQ. We have 3 chloride ions, and that's AQ. On the other side, we'll leave our solid intact. We have 3 Na positive, AQ, and 3 chlorides, AQ. Next step is to cancel out everything that's AQ on both sides. My hydroxide's not, but my sodiums are AQ, so I can cancel those. And my chlorides as well, because they're AQ on both sides. What you're left with is the net ionic equation. 3OH minus AQ plus Fe plus 3 AQ yields FeOH3, and that is a solid, which I forgot to put that up there. That is your net ionic equation. Your spectator ions are the ones that we circled that stay aqueous on both sides of the equation.